2,801. And minus T, which we need to figure out in just a second. Then solve for delta S. So whenever you look up delta H, delta G, or the entropy of formation, that's under standard state condition, which is 25 degrees. So for the temperature to use in this equation, we should use 25 degrees, but in this equation it has to be in degrees Kelvin. So this will be 298. So if we solve for delta S, the delta S is equal to minus plus 0.26, okay? And the units for delta S are going to be in kilojoules per mole per degree. Yeah, so it'll be kilojoules per mole per degree Kelvin. So is this reaction favored by entropy? Yeah, so this reaction is favored by both enthalpy and entropy. Okay, part D, does this reaction produce work? So maybe the other question is, would this be a good fuel? Would glucose be a good fuel to use in your car engine? You run out of gas, just get some glucose and pour it in your car engine. See if that works. Okay, so to figure out whether this reaction produces work, let's see, we want to figure out the moles of gas reactants and gas products. Let's see, how many moles of gas reactants do we have? Nope. 6. Yeah, 6. So note that this is a solid, so we have 6 moles of gas reactants. And how many moles of gas products do we have? 6. Yeah, 6. So this tells us that delta N is equal to 0, which means that delta V is equal to 0, which means that work is equal to 0. Okay, are there any questions on question 2? Okay, let's go back a couple of slides and look at this question here. So, did we do all the questions? Did we do finish this for the methane combustion reaction last Thursday? We did methane? Okay, so that means let's do NaCl and boiling water. So let's see, I'd like the 11 to 2 o'clock lab section to answer these questions for NaCl dissolution. I'd like the 2 to 5 lab section to answer these questions for boiling water. So let's see, since there's about, let's see, more than 30 of you in the 11 o'clock section, there's about 25 of you in the 2 o'clock section. If you work in parallel, like a computer, that means you're all working together, which means you should be able to finish this problem in about 13 seconds. If you work linearly, which us humans do, then it takes longer than that. So I'm not quite sure if you guys are going to work as parallel processors when you're answering these questions, or if you're going to work like a normal person and figure it out in a linear fashion, do it step by step. So. Okay, so again, the 11 o'clock lab section did the NaCl dissolution. The 2 o'clock lab section answers these questions for boiling water. So I hope that all of you who have to file taxes got your taxes in today. I got mine in 2 days ago. I figured since I got to pay taxes, I was like, I don't get it. I also want to remind you that Rex back there is videotaping these lectures, and the lectures are posted on his YouTube channel. I looked at it last week just to see how many views, and most of them only have a handful of views. So you're telling me last semester that you found these videos to be valuable for you to help you study, but is the problem going to YouTube, or is the problem videos not being on the Hartnell College website, or something else? Because Rex has been generous enough to donate his time and energy to videotape free.
Yeah, thanks, Rex. So you look all brighter, right? Maybe we set it back down.
It's not spontaneous. It's not spontaneous.
So is water excellent?
Yeah. So I have to change first.
Yeah, so that's fine. So work with mentors, that means
That's an 8. Is provided with minus reactor.
Yeah, 1 minus 0. It's negative 1. Oh, I'm sorry. 1 positive 1.
Yeah.
So I have 1 positive 1, right? So the work is greater than 1.
Here, buddy.
It's up there. It's negative 37. All right, calm yourself, Jack.
Okay, so for the NaCl dissolution, what is the chemical equation that represents that reaction? NaCl solid. Okay, good. And for the boiling water, how can you represent that reaction by a chemical equation? Right? E plus
H2O.
Okay, good. Okay, so for question B, is the NaCl dissolution reaction exothermic? So is this exothermic? So what observation But experimental observation tells you it is not exothermic but endothermic. Because when you put NaCl in water to dissolve it, no, that's not. See, that's not an observation which tells you it's endothermic. Yeah, so you add salt to water, and what observation tells you that this reaction is endothermic? Yeah, so note that when you do this, water gets colder, so the water temperature drops, it gets colder, which means that heat is being removed from the water, which means that heat is being gained by the NaCl. Okay, so this reaction, so this means that the H2O loses heat, and then the NaCl reaction gains heat, which means that delta H is greater than 0. Let's take a look at this reaction. So for part B, is this reaction exothermic or endothermic?